Let us now move on to example 2 for type 4 problem. The problem here is a bag contains 5 white, 7 red, and 8 black balls. If 4 balls are drawn one by one without replacement, four balls are drawn one by one without replacement. And as I told you, that if it is not mentioned with replacement, you will assume it to be without replacement. So here it's mentioned without replacement. Find the probability of getting all white balls. Find the probability of getting all white balls. Okay. So the question here is,
Okay, sir.
this is your bag. It contains 5 white balls, 7 red balls, and 8 black balls. Okay. 4 balls are drawn one by one. Okay. So 4 balls are drawn one by one. Okay. 4 balls one by one without replacement. Find the probability that of getting all white balls. So let us define the events first. Let us define the following events. What would be the first event? The first event will be all white balls drawn. Okay, all white balls drawn. This is your question. So that is our first event. The next event that I'm going to draw write is that since the question is drawing of all white balls, so the next event that will be white ball drawn, white ball taken out in the first drawing. In the first drawing. Next event, again white ball taken out in the second drawing. Third event, white ball taken out in the third drawing. And fourth event is white ball taken out in the fourth drawing. Right? So what is your E? What is your E? E is white ball in the first drawing and white ball in the second drawing and white ball in the third drawing and white ball in the third drawing. That means what is the probability of this event? Is equal to PA intersection B intersection C intersection D, which is PA into PB into PC into PD, because A, B, C, D are independent events. Since A, B, C, and D are independent events, right? So therefore, what is PA here?
Yes, sir.
What is PA? White ball taken out in the first drawing. Now look at this. How many white balls? 5 white balls, right? How many total number of balls? 5 plus 7, 12. 12 plus 8, 20. 20 balls. So white ball drawn in at first you have a total of 20 balls. And we are drawing out a white ball. So 5 by 20 is the probability, right? What
Yes,
is the
sir.
probability of white ball in the second drawing? Now see, one white ball I've already taken out and I'm not putting it back. So now how many balls are left? One white ball has been taken out. From now 20 balls and now it becomes 19 balls, right? And one white ball I have already taken out, right? So how many white balls left? Only 4 white balls left, right?
Overall, yes, sir.
So 4 by 19 will be probability. What is the probability of the event C in the third drawing a white ball?
Yes.
See, 4 white balls were left. Now again one white ball I've taken out. So only 3 white balls left. And how many balls left? 18 balls left, right? And the probability of taking a white ball in the fourth drawing. 3 white balls were there. In the fourth drawing, how many white balls are there? There are only 2 white balls left, right?
Yes, sir.
And how many balls left? 17 balls left, right? Hence,
Yes, sir.
what is the probability of the event? Is equal to 5 by 20 into 4 by 19 into 3 by 18 into 2 by 70. That's it. You calculate this to be 1 by 969. Is this problem clear?
Yes, sir.
Okay, so let us now move on to miscellaneous problems. 2 problems I've already done. Miscellaneous problems. These problems will be a mix of 1, 2, 3, and 4. You will have to decide which case this is. Okay. So first, problem 1. 2 balls are drawn at random from a bag. Two balls are drawn at random from a bag containing 3 white, 3 red, and 4 black balls. One by one without replacement. One by one without replacement. So
Without
the word has already been mentioned here, without replacement. That means it has to be case problem type 4, isn't it?
Yes, sir.
Find the probability find the probability that both balls are of different colors. That both balls are of different colors. Okay. Solution.
Okay, sir.
Let's see. First, how many balls are there in the bag? 3 white, 3 red, and 4 black. Okay. And they are drawn one by one without. How many balls are drawn? 2 balls are drawn. Okay. So, what will be the first event? What will be the first event? First event will be
First event is
the question, right? Both balls drawn are of different colors,
yes,
right?
sir. Yes, sir.
Are of different colors. Okay. Now, see, these balls that are drawn, they are of different colors, right? These 2 balls that I am
Yes, sir.
drawing, they must be of different colors. And how many colors are there? There are 3 colors, right? So,
Yes, sir.
how can the balls be of different colors if one ball is white and the other ball is non-white, right? Isn't it? If
Yes,
2
sir.
balls I am drawing, one ball is white and the other ball is non-white, right? So, A, if I define the
Yes, sir.
event that one white ball, one white, and 2 non-white balls drawn, not 2, one, one white, one white ball drawn. Then what is the complement of this event? A bar. A bar is one non-white ball drawn,
Yes, sir.
right? Right? Isn't it? Or you can do it this way also.
Yes, sir.
Since there are only 3 colors, what you can do is you can say one white ball and one red ball, right? 2 different colors.
Yes,
Event B, one white ball and one black ball, right? Again, they are different colors, right?
yes,
Next
sir.
can be one red ball and one white ball, right? Or instead of defining this way, let us proceed the other, because again the question of mutually exclusive will come in the picture. Okay, so this is the easier way. One white ball one white ball drawn, right? Then the complementary event will be one non-white ball drawn. If I define the event B as one red ball drawn, then the event B bar will be one non-red ball drawn, right?
Yes, sir.
If I define the event C as one black ball drawn, then C bar will be one non-black ball drawn, right? So therefore, what is the event
Yes, sir.
E? What is the event E? E is one white ball and one non-white ball, right? Or one red ball and one non-red ball, right? And
Yes, sir.
one black ball and one non-black ball. Now all these events are mutually exclusive. This are mutually exclusive. So you can add up the probabilities, right or wrong? You can add up the probabilities, right?
Yes, sir.
That means because why? Because they are mutually exclusive. Therefore, P is P A intersection A bar plus P B intersection B bar plus P C intersection C bar. Now A and A bar, since A, B, C are independent events, A bar, B bar, C bar are also independent events. So this can be written as PA into PA bar, right? Plus PB into PB bar, isn't it? Plus
Yes, sir.
PC into PC bar, right?
Yes, sir.
So now let us calculate the probabilities. Here, what is PA? Probability of the event A. How many white balls are there? What is the event A? One white ball, right? How many white balls? Three white balls. How many total
Yes,
number of balls? 10.
3 eyeballs.
So 3 by 10, right? Probability of A, right? And what is the probability of the complementary event? It is 1 minus PA, right? 1 minus 3 by 10
Yes, sir.
is uh, okay. 1 minus 3 by 10, which is 7 by 10. Next, PB. What is PB? What is event B? One red ball drawn. How many red balls? 3. So again 3 by 10. So what is PB bar? 1 minus PB, which is again 1 minus 3 by 10, which is 7 by 10, right? How about PC?
Yes, sir.
PC is one black ball. How many black balls? 4. Total number of balls 10. So 4 by 10. You understood this? Which is 1 minus 4
Yes,
by
sir.
10, which is 6 by 10. So therefore, what should be the probability? Hence, P is equal to PA is 3 by 10, PA bar is 7 by 10, plus PB is 3 by 10, PB bar is 7 by 10, plus PC is 4 by 10, and this is 6 by 10, right? So how much are we getting? 21 plus 21 plus 24 divided by 100. How much is this? 66 divided by 100. So your answer is 0.66. Any questions
Mm.
related to this problem? No question?
No, sir.
Remember, whatever problem that I am doing, all these problems are the only types that you can expect. There are no other types that you can expect. Clear?
Yes, sir.
Let us see this. A bag X contains 3 white balls and 2 black balls and another bag Y contains another bag Y contains 2 white balls and 4 black balls. Okay, so 2 bags, right? A bag and a ball out of it are picked at random. A bag and a ball are picked out of it at random. Okay, what is the probability that the ball is white? That the ball is white. Okay, solution.
Okay.
Now see here, there are 2 bags. Okay, let's draw the bags. This is your bag X, okay, and this is your bag Y. Bag X contains how many? 3 white and 2 black balls. Bag Y contains how many? Yes, I can hear you. 4 black. Okay. Yes, I can hear you. Okay. So now, what event should I define? First of all, I will define the event T. What should be the event T, Amir?
So the event E.
Event T will be the question. What is the question? The question is that the ball drawn is
So
white.
white.
So I will say ball drawn is white. Right? Based on the question. Now the question, see, look, read the question now. These 2 bags are there. And what happens? I don't know which bag I'm drawing first. I can draw this bag first and this bag second, right? Isn't it? In fact, I'm not drawing from both the bags. In fact, I'm choosing the bags. Okay. If you read the question, it states that I am choosing the bags. I can draw from any of the 2 bags. Either I can draw from bag X or I can draw from bag Y. Okay. So either I can draw from this. Let me write or here. So either I can draw one ball from this bag or I can draw one ball from this bag, right? But I'm only drawing one ball and I'm choosing the bag at random. Be very clear with this. Okay. I'm choosing the bag at random. I don't know which bag I'm drawing from. I can either draw from bag X or I can draw from bag Y. So what I'll do is I'll define my first event as bag X is chosen, right? Event B as bag Y is chosen. Understood? Because I'm choosing the bags,
Yes,
any
sir.
one of the 2 bags. Then I'm drawing. Next, I will say the event C. What should be the event C? If I have chosen the bag X, then I will draw a white ball from bag X. So I'll say one white ball drawn from bag X. Drawn from bag X. Clear with this? Event D, if I choose the
Yes,
bag Y, then I'm drawing one white ball from bag Y.
yes,
Okay. So what is E composed of? Therefore, E is equal to, I choose bag X and I draw one white ball from bag X. Clear with this? A intersection C. I choose bag X and I draw one white ball from bag X. Clear?
yes, sir.
Or what I can do is union for or. What I can do is I can choose bag Y, right? And I can draw one white ball from bag Y. These two are mutually exclusive, isn't it? Because once I've drawn from bag X, I cannot draw from bag Y,
Yes, sir.
isn't it? If I've chosen bag X,
Yes,
then
sir.
I cannot draw it from bag Y. If they are mutually exclusive, that means I can add up the probabilities. That means PE is equal to P A intersection C plus P B intersection B. Understood? Because they are mutually exclusive.
Yes, sir.
Now what happens? A and C are independent events. So I can write PA intersection C is equal to PA into PC plus B and D are also independent. So I can write PB into PD,
Yes,
right? Now what is PA?
yes, sir.
What is PA? Probability that bag X is chosen. Two bags are there. I want to
Sir, can
choose
you
one
hear
bag.
me?
Yes, I can hear you. Two bags are there, of which I have to choose bag X. What is the probability? Half, right? Right or wrong?
Yes, sir.
If I what is the probability of choosing bag Y? Again half, because two bags are there. What is the probability that I am choosing a white ball from bag X? How many white balls are there? Three white balls in the bag. So what is the probability of getting a white ball from bag X? 3 by 5, right? What is the probability of getting one white ball from bag Y? How many white balls? Two. Total number of balls, 6. So this is 2 by 6. Hence, what is PE? Hence, what is PE? PE is half. Put the values. PA into PC. What is PC? 3 by 5. And PB is half into PD. PD is 2 by 6. That's it. That should give you the answer. These two cancel. So you'll get 3 by 10 plus 1 by 6. LCM 30. 9 plus 5, which is 14 by 30, which is 7 by 15. That's your answer. Any problem with this question? Any part? Did you understand how to
No, sir.
define the events? Did you understand how to define
Yes,
the
sir.
events? Okay.
Yes,
Yes, sir.
yes, sir.
Next, problem 4. A speaks truth. A speaks truth in 75% and B in 80% of the cases. In 80% of the cases. In what percent of cases? In what percent of cases are they likely to contradict each other. To contradict each other in narrating the same incident. Narrating the same incident. Now tell me, first of all, identify what problem type this is. Tell me what problem type this is. They will contradict, right? That is the what you asked to calculate. Suppose Govinda is there and Amir is there. Amir speaks the truth in 75% of the cases. Govinda speaks the truth in 80% of the cases, right? When will you contradict each other? When either Amir speaks the truth and Govinda speaks lies, right? Right or wrong?
Yes, sir.
If Amir speaks the truth, Govinda lies, then they will contradict each other, right? Isn't it? Yes, tell
Yes,
me.
sir.
Otherwise, what can be the other case?
Yes, sir.
What can be the other case? Amir lies and Govinda speaks the truth. Even then, they will contradict each other,
Yes, sir.
right? So these two must be mutually exclusive. So let us define what. So what problem? What type of problem this is? At least one or exactly one?
At least one.
At least one. Why at least one? Why at least one? In at least one, that means what if both of you speak the truth? Then what happens? You're not contradicting each other. Yes. If I say at least Govinda speaks the truth, then what happens? That means Govinda and Amir can also speak the truth. Both can speak the truth, right or wrong?
Yes, sir.
But if both of you speak the truth, then you will not contradict each other, right? In order to contradict each other, exactly one of them has to speak the truth, and the other has to lie, right?
Yes, sir.
So that means this is what problem type 2,
Yes, sir.
isn't it? Where exactly one of them is lying.
Yes, sir.
That means we define the following events. Let us define the following events. What are the events? First, E, that A and B contradict each other, right? That is the question. A and B contradict each other, right? Let us define the event. Since A and B are already there given, let us define this event to be X. What is the event X? That A speaks the truth, right?
Yes, sir.
Then what is the complementary event? A lies, isn't it? Let us define the event Y.
Yes, sir.
B speaks the truth. What is the complementary event? B lies. And when will they contradict each other? E. When will they contradict each other? A speaks the truth and what? B lies, right? Or
Yes, sir.
A lies and B
Yes,
speaks
sir.
the truth. Now check whether you have understood this.
Yes, I understood.
And these are mutually exclusive. That means you can add up the probabilities.
Yes, sir. We have understood. Yes, sir. P of E is equal to P of X inter I y bar union with the class.
Now these two are independent events. Therefore, you can write this as px into py bar plus px bar into py. You can write what is py bar? Py bar is nothing but 1 minus py, right? And what is px bar? 1 minus
Yes, sir.
px into py. Now let us calculate the probabilities. What is px? What is the x event? X event is A speaks the truth. A speaks the truth in 75% of the cases. So what is the probability? 75 by 100, right?
75 by 100.
What is PY?
Yes,
PY, the
Yes,
event
sir.
Y is B
yes,
speaks the
sir.
truth. And B speaks the truth in how many cases?
Sir, 80
80% of
by
the cases.
100.
So 80 by 100,
Yes, yes, sir.
right?
Yes, sir.
That's it. Just put the values now. You can cancel also. 3, 4, and this is 4, 5. So therefore, hence PE is equal to PX 3 by 4 into 1 minus 4 by 5 plus 1 minus px into py, which is 4 by 5. That's it, which is equal to 3 by 4.
Yes, sir.
Take the LCM, you get 1 by 5 plus 4 minus 3, which is 1/4, which is 4/5, which is 3 plus 4 divided by 20, which is 7 by 20, right? Now, but they have asked you the percentage. Therefore, what is the
Yes,
percentage?
sir.
In what percent cases? Therefore, percentage of cases, percentage of cases in which they contradict each other. What is the percent? Can you tell me? Convert 7 by 20 to percent.
Yes, sir.
What? 7,
Possibility.
7 by 20 into 100. That's it.
Someone is converting.
That means 35%
Yes,
of the
sir.
cases they contradict each other. That's it. Clear with this? Or any problem?
Yes, sir. No, sir.
Just give me a minute. A student takes his examination. Takes his examination in 4 subjects. What are the subjects? They call the subjects alpha, beta, gamma, delta. Okay. They are calling they have given imaginary names to the subjects. Okay. He estimates his chance of passing he estimates his chance of passing in alpha as 4 by 5, in beta as 3 by 4, in gamma as 5 by 6, and in delta as 2 by 3. To qualify, he must pass in alpha. To qualify, he must pass in alpha and at least 2 other subjects. and at least 2 other subjects. Okay. What is the probability that he qualifies? What is the probability that he qualifies? Yes. So now, can you tell me what is the probability that he qualifies? Yes, tell me. Can you say which type this is?
Mm,
See, this is, let me first explain the problem. 4 subjects are there, alpha, beta, gamma, delta, okay? And the probabilities of passing are given to you. 4 by 5, 3 by 5, 5 by 6, 2 by 3. Now, there is a student, okay? And he wants to qualify this examination, but there's a condition to qualify. What is the condition to qualify? The condition to qualify is that he must pass in alpha. Definitely. Okay, whether he fails in others or not, that is different story. But he must pass in alpha. Okay. And at least 2 other subjects. That means at least 2 other subjects means he can pass in beta gamma, he can pass in beta delta, okay, and he can pass in gamma delta. Any of the 3. Okay. Then
Okay.
what is the, what type can he say? Now can you tell me what type is this? Can you tell me what type this is? At least one. Tell me. At least one. Yes.
at most, almost,
No,
or
is it at least
almost.
one? Is it at least one? First tell me
No,
this.
sir.
Definitely not. So type 1 is
Yes,
out.
sir.
Is it exactly
No,
1
no, sir.
or exactly 2 or exactly 3?
Exactly. So I think this one only.
Exactly 3
Exactly
subjects
right.
he must
At
qualify.
least,
Yes, sir.
He must qualify exactly 3 subjects,
yes,
right?
sir.
Yes, sir.
Whatever be the combination out of 4, but he must qualify in exactly 3 subjects. Okay. So that means, let us define the following events. Once we have decided that this is type 2, we define the events. What are the events? First event E, based on your question. What is the question? Probability that he qualifies. So the student qualifies, right? This is my first event. The student qualifies based on the question.
Probability that he qualifies.
Yes. What should be the event A? The first event. You have the subjects alpha, beta, gamma, delta. The probabilities of passing are
The
given.
student. Yes,
A,
sir.
so A must be the student
Yes,
passes in
sir.
alpha, right?
Yes, sir.
Passes in alpha. Then what is A bar? The student fails in alpha.
The student fails in. Yes, sir.
Next, event B. The student passes in beta.
It is in
B bar. The student
beta.
fails
Yes,
in beta. Because the
sir.
probabilities are given, that is why I'm defining the event based on the probabilities. C is the student passes in gamma, right?
Yes,
C
sir.
bar is the student fails in gamma, right? D is
Yes.
the student passes in delta, and D bar is the student fails in delta. Therefore, in what way can the student qualify? Tell me. Therefore, E, the student passes in alpha, right? Definitely he has to pass in alpha. There is no other way out, right? So student passes in alpha and
Yes.
he passes in beta and he passes in gamma, and he fails in delta, right? This is one way it can happen, right? This is one way of qualifying. What is the next way of qualifying?
Yes, sir.
He passes in alpha.
Uh,
Next, he passes in beta.
passes in beta
Next, he fails in
but
gamma,
fails in
and he
gamma
passes in delta.
and
This is another
passes
way
in
of qualifying.
alpha.
Next, what is the next way of qualifying? He passes in alpha because he has to pass in alpha. Okay, there's no other way out. Next, he fails in beta, he passes in gamma, and he passes in delta. Any other way of qualifying? Any other way?
Yes.
What way?
No, sir.
Why not?
No, sir.
Why not? He can pass it on. He can
Because
pass in
sir,
all.
yes, sir, yes, sir.
So A intersection B intersection C intersection D. He can pass in all also. He has to pass in exactly
Yes, sir.
three, but that does not mean he cannot pass in all, right? And these are mutually exclusive. Therefore, PE must be equal to PA intersection B intersection C intersection D bar plus PA intersection B intersection C bar intersection D plus PA intersection B bar intersection C intersection D plus PA intersection B intersection C intersection D. Now what? These are independent events, right? Passing in each examination, or are they
Yes,
dependent
sir.
events?
Uh, the independent event.
Independent. You pass in maths and you pass in accounts. Are they related? They're not related. You can pass in maths, you can fail in
Yes, sir.
accounts also, no problem, isn't it? So they have to be independent. You're passing in maths does not mean you'll pass in accounts also. Right? Now what is the probabilities of passing? What is PA? Look at the question. Probabilities are given, right? PA is 4 by 5,
Yes, sir.
PB is 3 by 4, PC is 5 by 6, PD is 2 by 3.
2 by 3.
So
Yes,
PA
sir.
is 4 by 5, PB is 3 by 4, PC is 5 by 6, and PD is 2 by 3. Right? Now you can put the values here. Therefore, I'm not putting the values, okay?
Yes,
You can find PE. You can do it on your own, right?
yes, sir.
You
Yes,
can
We will
find
yes, sir.
definitely.
PE to be 61 by 60, 61 by 90 you can find. Okay. So that is another type of problem. Okay. Um, let us see this problem. We are about to run out of time also, 10 minutes. Problem 6. Okay. There are two bags. One bag contains 4 white and 2 black balls. One bag contains 4 white and 2 black balls. Second bag contains 5 white and 4 black balls. Two balls are transferred from first bag to the second bag. Two balls are transferred. Very, very important problem. You have to understand this. Two balls are transferred from first bag to the second bag. Then one ball is taken from the second bag. Then one ball is taken out from the second bag. Find the probability that it is white. That it is white. Clear? Have you
Yes, sir.
understood the problem? Let us first understand the problem. Two bags are
Yes,
there,
sir.
okay? Two bags are there. This bag contains how many? 4 white and 2 black balls. Okay. And this bag contains 5 white and 4 black balls. Now what happens? Let us say this is bag 1 and let us say this is bag 2. Okay. That is they have mentioned already first and second bag. Now two balls are transferred from this bag to this bag. Two balls. Okay. Once two balls are transferred, now one ball is taken out from this bag. Question is find the probability that it is white. Understood? Did you understand the question?
Yes, sir.
Yes. Mr. Govinda, did you understand the question?
Yes, sir.
You understood the question. Very good if you understood the question. Fine. If you have understood the question, then